What is ferritic stainless steel? Well, stainless steel, it's a huge number of iron-based metals, and all of them characterized by having at least 10.5% chromium, maximum 1.2% carbon. And since about half of it is going to be iron, then we have about 40%, which can be virtually anything, the whole periodic table. Most commonly we add nickel, maybe we add titanium, niobium, sulfur, phosphorus, silicon, anything, but as long as the first three conditions are fulfilled, we're allowed to call it stainless steel. So what are the ferritics? Yeah, well, one of the most common elements to add to stainless steel, that's nickel. And for instance, in this one, IC304 or EN4301, it contains about 8% nickel, and the main reason to do so is because we obtain the face-centered cubic structure, and this face-centered cubic structure is excellent for stretching, for bending, for welding, which is the reason why every single elbow, every single tube on a dairy, on a pharmaceutical plant or in a butchery or whatever, it's made of austenitic stainless steel. What happens if we take away the 8% nickel? Then the steel stays in the body-centered cubic structure, which is this one to the left. This one contains, like the other one here, 17.5% chromium, but no nickel. So this one is body-centered cubic, this one is face-centered cubic. And mechanically, the body-centered cubic, the chromium steel, are far less stretchable, they're not quite as easy to weld, and because of the sensitivity towards heat treatment, you can only get it in up to like a thickness of 2 to 3 millimeters. And also mechanically, you can just see the difference by just using a simple magnet. The face-centered cubic is virtually non-magnetic, and the body-centered cubic is very magnetic. But what about, apart from the mechanical properties, there's some difference in chemical properties, that means corrosion resistance. Talking about the initiation of pitting corrosion is one of the most commonly seen types of corrosion for stainless steel. It's all dependent on the content of chromium, molybdenum and nitrogen. Neither of these do contain any molybdenum, no nitrogen. So it's all dependent on chromium, and the 4301 contains 17.5% chromium, and so does the 4509 ferritic chromium steel here. So they are equally resistant towards the initiation of pitting corrosion. Partly this applies for crevice corrosion as well. Talking about general corrosion, which usually occurs in very, very strong acid media, the nickel is very important, and for this reason the ferritic chromium steel are not very good. But on the plus side, they're actually very good against the worst of all types of corrosion, stress corrosion cracking. And this is a fantastic example. Some people, especially the customer, wouldn't call it fantastic, but I do. This elbow has been attacked very, very distinctly by stress corrosion cracking, which gives rise to these more or less beautiful cracks. But this type of corrosion doesn't really happen, at least not in normal media, to the ferritic stainless steel, so they're actually, in this respect, better. So there are a lot of applications where we should consider using the ferritic stainless steel as opposed to the normal austenitics. The most important reason in everyday use is actually the price. Because in 2005 and 2006, the nickel price really went up, very far up. It peaked in the middle of 2007 at a price of about $55,000 for a ton of nickel. And if the steel contains 8% nickel, then $55 per kilo, that actually makes quite an impact. If you can get away with getting the same corrosion resistance, avoiding the nickel, then it's actually quite a good idea. And that's the mainly reason why the ferritic chromium steel suddenly gained a lot of momentum in 2005, 6 and 7. And they still do. Back in 2007, when the nickel price peaked to the price of $55 per kilo, you can save $1, $1.50 a kilo just going from the face center cubic to the body center cubic. These days it's a bit less, it's more like 30-40 cents, but it's still quite a good way of saving a bit of money. So definitely the ferritic stainless steel should be considered. They're absolutely not dead. There's a great market for these ones, so give it a go.